All right, so I'm going to get started with a few announcements before we actually get into the meat of today's lecture. First off, you probably are all well aware of the fact that spring break is coming, which is awesome for you guys. It'll be a nice break. I do encourage you to actually try to take a little bit of a break, take a breather, reflect on what you've learned, think about where you're going from here. It's always a good time to kind of take that break halfway through the semester, and then we come back and we really put the pedal down to finish this off. You guys have made great progress thus far in learning to use Rhino, and so I'm really happy. And when we get back is kind of when we get started on the final project of the semester, and that's when things start to get pretty fun. So as part of that, however, I want to talk about what's coming up in terms of spring break, what you have to do. I don't have anything set up and assigned for you to do over spring break. So you have no homework, which is important. When we're done today with your exercise 217, you will have all the tools necessary to complete your assignment 203. Assignment 203 is not due on the Monday when you get back from spring break. It's a week from that Monday. So it's Monday, the 11th of April is when this is going to be due. So you have a week when you get back to finish things up. However, you have all the tools ready and at your disposal to start working on it and to get ready. I want to go over that assignment just a little bit to make sure that you're not missing anything and that you're ready for it. Number one, the building that you're building is actually larger than the one we've been using in class. So you're going to build a new building that's taller. It's going to be 808 feet taller. Same setup where you have a 20-foot lobby. It's actually 24-foot floor to floor. We're going to do 4 feet between the floors. And then all the rest of the floors are at 16 feet floor to floor with 12-foot clear. So there's that 4-foot gap in between the floors. So it's the same setup, it's just taller. And that's what you're going to be using for the assignment. So it's a little bit different than your previous building. And I encourage you to kind of adapt it a little bit and create it. A lot of what we learned today about unrolling surfaces will feed into your design of your final building for assignment 203. In part two, you're going to be doing renderings. I expect there to be an HDRI and a sun. So we're looking for a cloudy sky using one of those HDRI backgrounds and also a sun that's installed that matches up with the sky. You're going to be giving me 3 total renderings of your cityscape. 2 of them are already set up for you. So you have perspective 1 and perspective 2 in the San Francisco downtown scene. You're going to have to set up the 3rd perspective for yourself. And then part 3 and part 4, that's what we're working on today. We unfortunately don't get the opportunity to actually build these in person, but we're going to practice and prep as if we were going to build them in person in 2 different methods. One is building it out of paper by unrolling the surfaces and gluing it together. And the other is by 3D printing the skyscraper. So in both cases, we would need a laser cutter. In one case we need a laser cutter, in the other case we need a 3D printer. And I don't think you guys have a laser cutter and the 3D printer sitting at home. Some of you may have a 3D printer, but unlikely for the laser cutter. So it's not a requirement as part of this assignment to actually make the physical model, but it is required that you will create the prep files for it. So we're going to talk about how do you create the prep file for your 3D print. And we're also going to talk about how do you create the prep file of your unrolled surfaces such that you can build it out of paper. So that's what we're going to be doing today in class. So today's exercise is very much in line here. It's exercise 217, and we're going to go through and start to look at how do we unroll the surfaces, and then also how do we build a watertight model for 3D printing. So I have those set up for you on Canvas. There are tutorials that refer to my website that will take you outside that you can follow step by step with exactly what it is that I'm doing in lecture today. So that being said, it's time to switch over into Rhino. I'm using the remote desktop at school, and I've prepped this file by bringing 3 buildings together. And I've done this on purpose because I want you to see how these buildings unroll and how the pieces come together. And the 3rd option, while not as sophisticated, has some inherent problems in it. And so unrolling that object is going to be very difficult. And I want to show you how that plays out and how you might adjust and or switch it into being a little bit easier as a design. So first off, when we think about ruled surfaces or unrollable surfaces, or what are called developable surfaces, I think it warrants taking a step back and actually discussing what is a ruled surface and how do they appear in buildings. And so frequently, I've pulled up some information here. Frequently, you've seen buildings that are created like this. So here is the Disney Concert Hall by Frank Gehry in LA. And you see these crazy shapes and you go, wow, you know, I would like to be able to do it. Maybe you go, oh my God, that's ugly. I mean, depending on your take on this. But these shapes had to have originated in some kind of a drawing program and then ultimately had to be built. And so those are, by their nature, difficult. If I sent you out and said, you have to build this now, this would be a complicated building to build. But they're using something to their advantage when they build something like this. So Frank Gehry knows this, and when he designs it, he's working with what are called ruled surfaces. So every one of these surfaces can twist in one direction, but it's also straight in one direction. So let's look here at some of the examples. And I think this one might be the best example. Let's see if I can make it any bigger than it was. Of course not. The idea behind a ruled surface is that, actually, this one's not too bad, is that at any place across the twisting surface, and obviously the surface itself is missing here, but we could connect one edge to the other edge with a straight line. And so the result looks like it's a twisting surface, but it is in fact a series of straight lines that are strung together. So if we went back to the Disney Concert Hall here, every one of these surfaces has a rail on this side and a rail on that side, but in between those two is always a straight line, no matter how it curves. Same thing happens with this curve. There's always a straight line between this top curve and the bottom curve. So when we start to think about and envision our buildings, we want to make sure that our buildings are similar and that we're using the same principle. So here's some other examples. And you can Google ruled surfaces or developable surfaces, and you can see a bunch of these examples. But it's always about the straight lines between two objects. Here's, again, a whole bunch more. Where we run into problems are when surfaces are not ruled. And so I'm going to show another example here just as an explanation. And this one, actually, the building itself is a ruled surface. It's fine. There's nothing wrong with it. But the individual panes that make up this Prada store in Tokyo are not ruled surfaces. So they're not flat glass panels. They're instead one of three designs. There is, of course, one flat glass panel, but there are several other types of glass panels here. It's going to let me look at any of these bigger. Yeah, they're not very big, but these panels that are inset, some of them bulge out, some of them bulge in, and some of them are flat. And every single one of these had to be custom produced at a special factory that made these panels. So they're not something that's readily available. You couldn't go buy a replacement. So let's say that somebody threw a rock through one of these windows. Well, unless you had extras, you would have a hard time replacing one of those because it's not a standard ruled surface. You can't use standard building materials to make this. And that's because it curves in two directions. It's kind of like a pillow. It curves in two directions. So in this case, in the Prada store, the factory in Italy that made all of those glass panels, they actually made a whole series of extra panels so that they could be replaced down the road if one of them were to break or crack. So while the dies and everything were set up to build them, they went ahead and produced extras. But when those run out, there's going to be a problem. So that's the problem with a non-ruled surface. So while the building itself is ruled here, the individual panes are not ruled, and they involve some extra special setup. So we could spend more time doing that, but let's go back to our buildings here in Rhino, and let's look at some of these surfaces. So this middle object here is the one that, let me hide these others for a second. This middle object here is the one that I created last class. So you remember it leaned a little bit. And as I look at this building, we have some hips and some changes and some twists, but in any one spot, there's always a straight line that can connect from one point to another. And you can actually see it in the edges of the floor, right? So we created all these floor planes, and that's always a straight line. It goes from here to there in a straight line. Even if we're up here on the building further, It's a straight line from here to there. So while the building appears to twist, it's built up of a series of straight lines. And that makes it a developable surface. So when we go to unroll this surface and flatten it out, we can actually flatten it out and then theoretically glue it back together to create this shape. If we had a building, however, let me show the other buildings here, like this one at the end. In this example, we have what looks like a ruled surface on the back side, on the front side here, and right there. There's a few problems with it. It's not quite ruled because of how I created it. But on this side, we have a bulge, and it curves in two directions. So it's curving this way, and it's curving that way. And I think the easiest way of explaining this concept is it's kind of like if I handed you an orange, and I said, I want you to peel the orange such that we could put it back together. We could glue it all back together and create the sphere out of the peeled orange. Well, you can't just unroll it and have it seam back together. You'd have to cut lots of little slits in it and try to glue it back together. You can't peel it off in one sheet because it has two-dimensional curvature. That's the nature of this problem. So when we do these unrolled surfaces, we don't want bulges like this. And if we have a bulge, we have to figure out how to simplify it such that we could unroll it. And actually, for that context, have an easier time building it in the real world. So for right now, let's hide this one. And we'll come back to it, and I'll show you what happens. Oops, I should have hit the control here. Let's hide this building here. And let's concentrate on the building that I created last class. So when I'm working with this, I really don't need any of the floors anymore. So I could turn the floors and the ceilings off. Oops, sorry, they're down here. Floors and ceilings off. And I also don't need the core. We're not going to worry about the core as part of this unrolled surface. What I do need is I need the skin of the building. So I'm going to select the skin, and ideally it's a closed poly surface. It's all joined together. And I want to make sure that I'm including both the top of the building and the bottom of the building in this surface. If it wasn't joined together, let's say that it was separate, and I went to try to select it, oops, I would need to come back and I would need to join all these segments together before I did the unroll. And it's going to make the unroll process much better. You don't technically have to do it, but it will keep track of your objects better, and it'll make the reassembly that much easier. So I would select all the pieces. And it looks like I have that one there. I would join them back together. Oops, let me turn off those ceilings so we're not distracted by it. And so now I have that one closed poly surface. So we can see up here in my command, when I join them together, 12 surfaces joined into one closed poly surface. Perfect. So let's go ahead and use the unroll surface command. It's available under, I think it's under surface. I so rarely actually find it in our command is unroll srf, but I never find it in the menu structure. So I'm struggling to find where it is. Huh, okay, well, we'll type it in because that's what I typically do. It's unroll, UNROLL SRF for unroll surface. And when I choose that, I have some options as we initially look at this command. So first off, explode set to yes or no. Well, if we don't explode it, we end up with an object that's all overlapping on itself. So generally speaking, you want explode set to yes. The other thing, by default, labels is set to no. You're going to want to make sure that that's set to yes. So click on labels and have it set to yes. You don't have to turn them on, but when you get a complicated shape and you try to reassemble it, the labels really, really help. So explode, yes. Labels, yes. Key properties, we can say no for right now. And our relative tolerance is fine, and our warning is fine. So it's going to then say select surface or polysurface to unroll. So let's go ahead and click that surface. So I've selected it. And when I hit enter, it's going to take the surface of the building, it's going to number it, and then it's going to unroll all of the polysurface edges and give me numbers to help me reassemble it. So let's take all of the objects that it just created. And let's go ahead and move them. So I typed in move, and I'm going to move them down here just to get them out of the way. I want to leave my object on, and I want to leave for a reference point, and I want to look at all of these objects here. So what I'm going to start looking for is similar numbers. And you'll see that the numbers start to appear and repeat. So here, right, actually, let's take this one here. I'm going to drag it over, and I see that 15 matches up with this number 15. So let's go ahead and move it. I'll snap to that corner. I'll move that there. Then we can do a rotate. It's not a 3D rotate, it's just a regular rotate to line up those two number 15s. And there it is. So now my 15s line up. So I'm looking for other numbers. So there's 20. There's 20. Let's go ahead and move those. I'm going to snap there. Snap there. And I'm going to go ahead and rotate. Again, it's just a regular rotate. And we'll come over and we'll snap there. So as we keep going, we have to start continuing to align these objects. So there's one. There's one. Move this one. There. Then we will rotate. There. We can also see there's a 3. Move. There. We'll rotate 3 around to match up there. Now we can keep going. So somewhere there's probably, let's see, there's an 8. Move. And then we'll rotate this. Let's see, 23. Move 23. There, and we'll rotate. Right, like that. 21. Rotate. Okay, I need to make sure that I'm getting the actual corner there. So we'll take that corner. We'll rotate it around to that point. And let's see, what else do we have? We should have an 11. There's an 11. Move. Rotate. There we go. We should have, there's 18. Let's move that. Rotate. And 5. Rotate. And so this is very much like those drills that you used to do in your 130 class, where you were trying to figure out how these shapes came together and unfolded flat. Oops, looks like those didn't quite rotate together correctly, so let's fix that. Rotate this one around first. There, I'll take both of these together and I will rotate them. And there we go. So what I've done is, if you envision this shape flattened out such that I could glue it back together with all of the sides, that new shape that I just created is actually the layout of what this building would look like unrolled. So the same process would happen. Let's go back to show all of my other objects. I'm missing the top and the bottom of. Not sure why I'm missing it. Anyway, I was going to go back to this object here. If I were to take this object, this is actually two objects. I could take those two, I could join them together, and then I could unroll those. So same thing, unroll SRF, and we're explode yes, labels yes, and we'll go ahead and hit enter. And there are the pieces for that building. So same thing, where I have all of the numbers and I could line those back up again. I'm not going to do it because you don't need to watch me create that. Now, if we get to this last one, remember this one I said would have a problem. It has the bulge and the curvature in two directions. When I have that and I go to unroll the surface, again, same options, explode yes, labels yes. Rhino used to throw an error at this point, but instead, and it just wouldn't do it. Now it says the unrolled surface area is not within the tolerance of the starting surface area. Okay, so yes, it will unroll it, but we're gonna miss out on this bulge because there's no way of stretching the flat sheet to accommodate that bulge. So if I go ahead and say close here, it will still do it, but the side with the bulge in it, which would be the numbers between 5 and 1, if we looked at it, right? There's 5 and 1, that's just flat. It doesn't have the bulge in two directions. So this wouldn't actually unroll in the same way that our first option would. So while it's technically unrolled, it wouldn't look like this. So in this context, if we wanted to have a building like this, we would need to find a way to flatten the sides. So we could, for example, take this, let me go ahead and explode it, and I could simplify this front face. So I can do that by extracting a curve from right there. So I'll use the extract ISO curve tool. I don't want it in the U direction, I want it in the V direction. And then I could snap to the middle here. I have to turn on my midpoint snap, here we go. And there it is. What that does is it gives me a curve here. Then I could duplicate the edges to create a curve there and a curve there. So with those edges, I could then take this edge, loft it to this edge. Remember, a loft is always a developable surface. And then I could take this right here, and I could loft it to this edge. And say, okay, now this, if I hide the original surface, you can see that my adaptation still has a curve, but we've eliminated the second dimension of curvature. It's just a straight line there and there. So this would be developable and unrollable in the same way. So if your building ends up having curvature in two directions, you may have to rebuild it. You may have to recreate it and make sure that you loft it around to get this end result. Okay, so let's talk about how would we actually create a laser cut file from this unrolled surface. So I have the unrolled surface here. I can actually, for cleanliness sake, let me hide the rest of this. Let's zoom, selected, and there we are. So if I were thinking of this as a laser cut file, I would need to create a layer for laser cut. And for cleanliness, let's put it down at the bottom. Well, let me just use the down arrow. There we go. There's my laser cut. Let's create a sublayer for cut. Remember, cuts are always in red, so we'll change the color over here into red. And then let's create a sublayer for engrave. And the engraves are always blue. So we'll change the color of that layer to blue. Let's make the engrave layer active. And then what we need to do is we need to duplicate the edges all the way around our objects. So I'm going to go ahead and type dupe edge. Now we could duplicate the borders, but we'd end up with repetitive lines. So I find it easier to actually walk yourself through. And it also gives you a way of kind of thinking as you create this, what is the outermost edge of this building? So I'm clicking my way around. Now, on some of your buildings, you may not be able to actually lay it out all in one piece because the pieces might overlap one another. And that does happen. So this, if I were to hit enter, will give me a set of curves around the outside of my building, all the way around the outside of the building. But I also want to think about fold lines because the engraves would end up being fold lines. So I want to go ahead and duplicate these interior edges. So I'll do dupe edge one more time. And I'll pick these surface edges. There we go. It doesn't matter which direction you pick. I'm going to pick this one and also that one. And I'll go ahead and hit enter. So at this point, if I turned off my default layer, we would see an outline of those buildings. In some cases, depending on the crease, you may or may not need to duplicate the edge in between there. It's not really a bad thing to do it, so let's go ahead and do it just to make sure, in case there's a little bit of a crease when we went to assemble it. And we'll go ahead and hit enter like that. So right now, these are all fold lines. They're not actually cut lines. So when we think about cutting this, if we were to cut this out, it would be really helpful to have some kind of a little like gluing surface to tab the two together. So if I was going to create that gluing surface, I really need to offset one of these to create that little bit of a tab. So let's use an offset. So I'll type in offset, and my distance here, probably going to be somewhere in the neighborhood of, I don't know, 25 feet. We'll try that. It's a little bit big. Let's do 15 feet. So let me do offset. My distance, we'll do 15 feet. And I'll pick this and I'll create that little tab. I might as well continue my way up and create that line. Now, because this edge, if we were to fold it, would glue to this edge, I don't need a glue tab on this edge or this edge. This edge here glues to that piece. So on either one of these, I would need a tab. So let's put a tab down at the bottom. I don't need it there. If we put a tab on this side, like that, I wouldn't need a tab here and here. Likewise, this edge would end up attaching to this point, so I can put the tab only over here. This edge would line up with this point, so we'll go ahead and put a tab, oops. Go ahead and put a tab right there, and that would line up there. To make this a little bit easier, let's put the tab there. That would glue to there. This tab here would glue to right there. This side is gluing to that edge. So there's that tab. This doesn't need any tabs because the tabs are over here to connect it. Excuse me, it does need a tab. This here connects to that edge. Okay, same thing where we've got these. This would need a tab there, and we can go ahead and put a tab there. So that edge connects here, this edge connects here. We have a tab that lines it up to there, and so we're good on our tabs. Let's go ahead and change those into cut lines. We know all the tabs are the outermost lines, so let's select all those tabs. I'm just holding down Shift as I do this. Oops. That one more time. And while I'm doing that, David was kind enough to point out that the unroll surface is available under surface flattening and then unroll surface. Okay, so I've gotten all of those. Let's change those onto the cut lines. Let's change object layer. Those are now all cut lines. We probably have to do a little trimming. So like, obviously we wouldn't want to cut into our building here. So let's go ahead and do a trim. I'm just going to say all. And then we can actually trim out. We don't need those. We don't need that. We don't need that. We don't need that. Okay, that looks pretty good. Okay, so let's make the cut line layer active. So as I keep drawing here, we need to go ahead and connect these. And I like to do the middles, just in case as you glue it together, you would need to modify. So that's a tab. It didn't quite connect all the way. There's a tab. There's the tab. So I'm just right-clicking to repeat the last command. Oops. I'm not going to worry about that. We need this one. And not that one. Not that one. And that there. And that right there. Okay, so we've worked our way all the way around. Now the balance of the sides still need to be cut out. So if we imagine cutting along here, well, this still needs to be cut out. So we actually need to change the layers of these so that we go all the way around the building and cut it out. Let's go to right there. That's good. Let's come around here. That needs to be selected. That one needs to be selected. That one needs to be selected. That does. And then this and this. So we'll change those onto the cut layer. And now, if we were to look at the shape, we could even look at it in the top view. So we're looking straight down on it. Select, oops. Zoom, enter, S for selected, enter. There we are looking at it. And what we're seeing here is we're seeing a cutout of what we would need to build this shape. So the red lines are the cut lines, the blue lines are the fold lines or the engraved lines. This is what I'm looking for both in your assignment 203 and as part of today's exercise. So if we had this and we were going to actually laser cut it, we would need to scale it down and get it on the appropriate size page. But for our purposes right now, we would take it and then we would export it to DWG. So I'd go to export selected. I would change my file type to DWG. Okay. But for the purposes of handing it in, I don't need the DWG. All I need is a screenshot of this red and blue lines. So I'll go up to my top menu here, or my top viewport. I'll come down to capture. And I'm going to capture to file. And this will save a JPEG of my lines. Go ahead and say OK. And we can put it on my OneDrive in today's folder. Let's go to 217. There we go. And this is the spring of 2022. And I'll click save. And so that gives me the JPEG of this. That's how I'm going to verify that you have it set up. Okay, so we've done that part. That is one method. That's a way of being able to cut out your building, glue it back together, and then you know, create a little model, a paper model. The other option would be to want to 3D print something. So I'm going to switch into my perspective view. And let's go into show so that I can see my other buildings here. We can turn back on my default layer. And let's work again with the skin of this building. So this is ultimately the one I want to 3D print. And I could go ahead and I could leave the core on like that. And then I could go ahead and kind of convert this object over into something to 3D print. Now, I would like to bring this out of this file and move it over into its own separate file without any other baggage associated with it. So all I really need is the skin and the elevator core. I'm not worried about the floors and ceilings because those are not things that we'd end up 3D printing. So I'll take the skin, I'll select it, I'll hold down Shift and select the elevator core. And then I'm going to go up to Edit and then choose Copy. That's different than Transform and Copy. This is copying it to the clipboard, which will then let me move it into a new Rhino file. So let's minimize this Rhino. Let's open up a new Rhino. So I'll do a new, we'll do large object inches. Perfect. And then we'll go ahead and go to Edit and then Paste. And when I paste that in, let's go into perspective here, let's zoom selected, there it is. So I've taken it effectively outside of the file that I was just working on, and then I've dropped it in a brand new file to work on. And that's always a good practice when you're gonna go do some 3D printing. Take only the parts that you really need. You don't need the surfaces, you don't need the floors, you just need the skin, and in this case, the elevator core. So let's move it over. Move. And I'm going to move it to 0.00, which is again going to help me. By the way, this whole tutorial is written out. If you go to my website and you go into tutorials, you can go into 3D printing from Rhino. It's under physical modeling and then 3D printing from Rhino. And this will walk you through everything that I'm doing right now. Okay. So it's there just for your backup. So as I look at this, we want this to be what's called a watertight object. And right now it's a little bit, it's not quite going to show the truth, because if I were to use the show edges command and I selected these two poly surfaces and I hit enter, we're looking for our naked edges. It's not going to show any. So technically this would look like we could 3D print it. The problem is I have two separate objects that are part of the 3D printing. I have the elevator core and I have the building itself. What I need to do is I need to make those into one object rather than two. So let's do some trimming. I'm going to switch over into my, I could do it in wireframe mode. I'm going to do it in ghosted mode. And I'll go ahead and I'll use trim. And when I select my cutting objects, I'm going to use the skin of the building as a cutting object. I'll go ahead and hit enter. And then I can trim out that elevator core. So I've gotten rid of it. That leaves me with the elevator at the top, the part that pokes out, and a little square at the bottom. Likewise, if I looked in here, this surface, this top surface, actually goes through where the elevator core is. So I need to do another trim. I'm going to go to edit and then trim. I'll use this as my cutting object, hit enter, and then I need to trim off the surface. And this is going to be a little bit hard to select because it's inside the building. So you may actually have to get yourself inside the building. Let me zoom selected on that. Let's get inside the building there. And now when I click it, I should, well, I lost it. Let me undo. Let me do it from the top instead. I'll take this little piece, I'll explode it. I can temporarily hide this top so I can look down on it. There we go. Let's switch back into regular shaded mode, not ghosted. I'll select the core, trim, and now I can trim that little bit out. Let's go ahead and type show. And now we have the elevator core. So it's a fully hollow object that has just that little piece sticking out of the top without any floors inside. So at this point, we need to see if there are any naked edges. This is what's called making a watertight model. So this, if we were to put a liquid inside it, wouldn't leak out on the sides. So we'll do that by typing the show edges command. And I'll do that when I type show edges. It says select surfaces, polysurfaces, or meshes for edge display. So we'll select all of it. Sorry, side effects of being sick. I'll go ahead and hit enter. And you saw this earlier, this edge analysis. We can show all the edges, or we can show what are called naked edges. And the naked edges show us wherever there is an unjoined, so sorry about that, polysurface. So now that I have those naked edges showing, you'll see that if I take these two surfaces, for example, and I join them, what used to be displayed as a naked edge there has gone away. Likewise, if I took that object and the top and type join, the naked edges along the front have gone away. So I'm going to keep working my way around. I'll select these. Like that. We'll type join. And we'll see that the naked edges have gone away there. Now I need to join this to this. And the naked edges have disappeared altogether. This is exactly what I want. So there's no naked edges at all. We can close this and we can do it one more time just to confirm. So edges, let's select this. And we want naked edges. It's not showing me, there's one little one down at the bottom. Remember that was that rectangle that was left over. We can go ahead and just delete that. There we go. And now we're not seeing any naked edges at all. That's good. This is what we need to be able to 3D print the file. So at this point, let's go ahead and save it. I'll go to File and then Save. And we can call this, I don't know. I call it the 3D print prep. I'll go ahead and save OK. Perfect. Now there is more to this. And so if you flip back over into this, we talked through that naked edges. I again suggest moving it to 0, 0, which I did. At this point, we need to go ahead and scale the model down. And I have some notes here for you to help you out, right? So if our model, if we wanted to go 3/4 of an inch equals 100 feet, and again, this would be based on the size of the 3D printer bed, how big could you actually make this object? And also, what scale did you want the object to display in and how long would it take to print? So at that, so at 100 feet equals 3/4 of an inch, our model is roughly 600 feet tall. It should be 4.5 inches. Alternatively, if it was 800 feet tall, it'd be 6.06 inches. Okay, so let's do 4.5. And so what I'll do is I'm going to scale this whole thing down so that the height is 4.5 inches. So let's select it. And I'm going to scale. And this is a scale 3D. So it's just a regular scale. And we'll pick one of these bottom corners. Now it's hard because I can't really snap to the upper building because it's twisting so much. So I'm going to do this in the front view. So I know what 600 feet is, so I'm going to turn on ortho, and I'm actually going to type in 600 feet to get an exact 600 feet. Whoops. That was wrong. Sorry about that. Let's do it one more time. Scale. And my first reference point should be, I need some coordinates here. Let's go 0, 600 feet. There's my reference point. And now I could make it bigger or I could make it smaller. In this case, we wanted it to be 4.5 inches. So I'll type 4.5 followed by the quotation mark for inches, and I'll hit enter. Now the building gets really, really small, and that's because it's designed to 3D print now at scale. So let's zoom selected, and there it is at a much, much smaller scale, and it's getting ready to 3D print. So that's the first thing that we did, is we scaled it. Let's save it again. Now, the next piece of this, and again, I'm referring to my notes here, is that we need to convert this over into a mesh file, because the 3D printer isn't going to read our NURB surface, our beautiful NURB surface. It's going to be looking for a mesh file. So if I select this object and I type in mesh, it's going to allow me to create a mesh. Now, this polygon mesh options allows me to choose the number of polygons, which is going to smooth out the sides. So the higher the number, the smoother this is going to be. The smaller the number, the less smooth it's going to be. You can preview it, so you can see how many little triangles it makes this up with. If we increase this number and hit preview, you'll see that there's many more. If we decrease this number, let's come all the way down here. We hit preview. There's very few, or there theoretically should be very few polygons that make up this. I guess that's the minimum number. So generally somewhere in the middle is probably pretty good. There we go. And we'll go ahead and say, okay. This then creates a mesh that is just like our building. So that's our building. And come on, let me see the mesh. Let's move the building to the side so you can see the two together here. Let's go over by 100 feet. Oh wait, sorry, we're at scale now. It'll only be a couple inches. Let's go 4 inches. Okay, so this was our original polysurface. This is now the mesh that looks like our polysurface. This is what's going to get 3D printed. So at this point, we can actually delete our original. Let me type in delete. We'll go back to just our polysurface right here. Let's move it. Now I can't snap anymore because this is a mesh. So I have to snap to my vertex and we'll go to 0, 0. There it is. And now I need to convert over my units. My units are still in inches because that's what I've been working in. The 3D printers tend to recognize millimeters. So we need to convert those units. So I'll go ahead and type units. Right? And when I switch from inches to millimeters, I'm going to say, okay. It's going to ask, do you want to scale? I believe the answer is yes. Let me just double check in my command here. Yes, we do want to scale. That was my recollection. I just wanted to make sure I wasn't wrong. We'll go ahead and say yes. And so our units are now in millimeters. It looks like our building got bigger, but it was just the conversion from units, from inches into millimeters. Okay, so we now have our object. At this point, we need to export it. I know there's a lot of steps involved in this, but it's an important process. So we need to export this as an OBJ or an STL file. Those are the two types of files that the 3D printer softwares tend to recognize. So I'm going to select it, and then I'll go up to File, and then Export Selected. And under the Save As type, we need to change it to either an OBJ or an STL. Either one of those will work. I'm going to use an OBJ for right now. And let's go into my flash drive. Actually, it's not my flash drive, into my OneDrive. And we will save this as spring of 2022. And we're going to be saving it as a polygon mesh object. We'll go ahead and say OK. And it makes our export. So in terms of what you're turning in, I'm going to ask you to turn this in, the .obj file, and that screen capture that we did of the lasercut file. That's what's required. That's also what's required as part of assignment 203. However, if you had access to a 3D printer, there's a little bit more involved. You have to get this file ready to 3D print. So I'm going to walk you through that process, but it's not required as part of the exercise or part of the assignment. So we've now finished what's required. Now this is the optional part and is designed to be a little bit more prep for you. One of the things that I also mentioned is if we get to the point where we can go in and 3D print or whatever, and you're interested in doing that, I'm happy to help you get set up so you could go into one of the lab hours and actually try printing this. Okay, so let's talk about how do we create this 3D print file. In order to 3D print, we need something called G-code. That's what's fed into the 3D printer, it tells it what to do. And to create that, we actually need, and I have this written out at the beginning here, we need a separate software program that will write that G-code for us. And so we're going to use the Cura program. There's a link to it right here. You'll need to install it on your own computer. They're not installed on the lab computers, so we can't use it from the lab computer. Instead, we need to install it. I already have downloaded it and installed it. Let me see if I can find it here. Right, so this is on my home computer. Here's the Utilimaker website. You can just Google Cura and it'll show up there. When you go to software, you can click on this link and then you can download it for free. You choose whether you're a Mac or Windows or Linux, I guess. I am using the Mac version, so I clicked on that, and I also I downloaded it and I installed it yesterday so that I'd be ready for it. So I'm going to go ahead and open up that piece of software. So let me get it going here. Almost done loading. Okay, and so this opens up the Cura software. Now it's possible that yours doesn't have a printer already set up in it. And if that's the case, that's fine. We need to go ahead and set that printer up. At school, we have two different printers. The only one that's available right now in this version of Cura is the Type A machines. So you might get this dialog box to begin with that says you need to add a printer. We're going to add a non-networked printer. And in terms of school, we have a Type A machine. So I'd come all the way down here to Type A machines. All right, the other one's a Delta Maker, but it's not supported by this version of Cura. There it is. And we go ahead and click on add. That would add the printer. I already have it added here, so it's right there. Now I need to go ahead and bring in my object. So that one that I just created. So I'll click on this file icon. And there it is. It was in my OneDrive, so hopefully it's had enough time to sync up. Otherwise, I can use one of my other files from before. So let's go into my OneDrive folder. And where are we here? No, Spring 2022 object file. There it is. So we'll go ahead and click on open. And that will then bring my object file into the 3D printer bed. And much like I've done in Rhino, right? I can orbit using a right click. If I need to pan, I can hold down the middle mouse. I can also select the object, which it is currently selected, and I can transform the object. So I could mirror it or rotate it, etc., as necessary. In this case, it's turned out on its side, and I'm not sure why it's not letting me change it. You know, you always love this when you do it live and something like this changes you. Why are you not letting me change it? Well, let me open another one. No, it won't even let me delete it. How about that? There it is. I don't know, wouldn't let me select it. Now I can. Let me orbit this object. Zoom out here a little bit. It's kind of like the gumball in, oh, come on. I'm going to try the select face to align to build plate and see if it'll let me do it. No, I don't know. Maybe this is a Mac problem that I'm having. You know, you do this stuff ahead of time and you prep so that you're ready. And of course, this happens when you go to do it live. All right, come over here. All right, one more time. No, it doesn't like me. Okay, well, I'll still walk you through the process. I would rather have this stand up on end because right now it would build a bunch of supports underneath the side, which would get kind of messy. But let's talk about the options. Up here, we have the ability to look at our options. They have recommended settings and they have custom settings. These custom settings are best given to you by whoever's in charge of the computer lab. They probably have a better understanding. In our case, Bob would have a better understanding of what these settings should be. Based on historical experience, however, I do have a quick rundown available here that talks through all of the settings that we've found work well on the Type A machines. So you would go through and you would edit every one of these. So the layer height would be 0.2, and then you'd come down to the wall thickness as 1.5, etc. It takes a while to go through the options, right? There's our layer height 0.2, wall thickness 1.5. We come down here, top and bottom thickness 1.5, etc. So you just keep expanding these and changing each of the settings as you go through. Okay. When you're all done, you would click this slice command right here. And that's what's generating the actual code for you that you would then feed into the printer. It tells you an estimate of how long it would take. So in this case, it would take 2 hours and 44 minutes to print. It tells you how much of the spool of print food you would need. And then you could save to disk your G-code file. Okay, so there it is, G-code. I could save it onto my computer, etc. Like I said, that's not required as part of the class, but it's something that you may want to be exposed to just so that you're ready when it comes time to actually do the 3D printing. Okay, so at this point, we've made it through what we need to. What I want you to do is I want you to concentrate on creating the OBJ file or the STL, your choice, and also the unrolled surface. So those are the two really important things that we're going to get out today. The one other thing I want to remind each of you is that I am being reviewed. It's one of the standard things that happens to faculty members over time. This happens to be the class that is being reviewed for me. When you first log into Canvas, you'll see a little pop-up that'll ask you to take a quick survey that talks about the class and the professor, etc. I would appreciate it if you would take the time to fill that out so that I can get your feedback. And with that, I will see you guys in your check-ins today. So first check-in begins at 12:10, and we'll go from there. Are there any questions before I let you guys head out? All right, sounds good. I'll see you guys in check-in.